Today we're going to look at a problem that is quite typical. It involves testing the fire and gas detectors on an onshore plant. This is very easy. It simply involves running a dispersion calculation, a few other steps, and we're loading the plant here. Just a PDF drawing of a plant called Plant 2S. Now you could see the plant here. This is the industrial area, and this is the residential area nearby. I'm going to deselect the lines that demarcate roads because I don't want the software to treat them as walls. So what I'll do is I'll just exclude everything, and I've done this before, so I'll just load a setup, and there we are. Okay, you could also do this manually by selecting each particular line segment and going exclude, and that doesn't take a long time at all. But we've covered this before, and so there's no need to do it again. Okay, so now we're just going to run a normal dispersion calculation. I'm going to select dispersion. I'm going to model a release from a vessel that is at a pressure of 1 megapascal. We'll go with the wind in the negative y direction. Note the axis orientation that Explo-CFD adopts. So in the negative y direction, meaning upwards, right? So I'm going to go -1, and the release in the same direction as well, -1. The hole size we can leave as 0.1. You could change it to whatever value you need, but we need to figure out what this panel size is. So I'm just going to close this for a minute, and then we're going to select the panel from which the release is going to be modeled. Now, typically, you don't have the resolution to model the actual hole physically, so you have to do a calculation to model the equivalent hole from a panel, and that's what we need to do. So I'm going to select this as a panel. I'm going to mark it as a release inlet. It turns blue, and then we need to measure its length from here to about here, and that is about 1.5 meters, yeah, according to the scale. So I've just done an automatic conversion, so I just need to put this in as 1.5, and we're ready to go. All we need to do is we need to put in the time step. Now the time step, I'm going to use a large time step. We're going to use a non-zero CFL so that it takes care of that, and we're going to model a simulation time of 350 seconds. You can run it for longer, but we want to get this over with quickly. And that's it. That's as easy as it is to run the dispersion. I'm going to perform analysis now, and we'll come back to look at the results and look at the performance of these fire and gas detectors. Yeah. Okay, so the results have been loaded into ParaView, and all you have to do is click apply. Remember, all we've done so far is just the standard dispersion calculation similar to the previous video, and you can plot things like density if you like, and you can also animate these things, animate the plume as it is ejected. Let's just orient it that way, and you can see the plume going from left to right. And of course that's not what we want. What we want is the release volume fraction as a starting point, and here it is. And remember that the problem here is, does this gas release, does it get detected by our fire and gas detector layout that we have for this plant? I'm just going to increase the darkness of this color here so that you can see the buildings more clearly. So all you have to do here is just simply go to load state and load this file from the root of Explo-CFD, and what you're doing now is calculating the locations and the performance of the gas detectors that are in this file. in this file, input file. Now I could show you here. This is the format. So here are the point detectors, the line detectors, and the sector detectors. These are actually fire detectors, so they're not really part of a gas detection scope. These are only for fire, but they'll still be plotted anyway. And this is the format. You could put as many as you need in the file. You can simply add lines to this file with the coordinates of the detectors, and it will show you, it will take those into account. And so here are our detectors, and you could see the point detectors here, and the line detectors over here, as well as the two fire detectors. And what you want to see is if any of the gas detectors are intersecting or have intersected with any of the plume at any point in time. So what you want to superimpose is the maximum release volume fraction across all time steps, and this is what it is. And here's what you're seeing. You're seeing that this line detector perhaps doesn't detect any of this. Perhaps if we go, we'll see, we can look at the results, but certainly this line detector has detected the gas, and this line detector may have detected the gas. And you can see which ones they are easily by going to the line max view over here and showing. So that's line max number 1, and this is line max number 2. So you can see those two, and these are the others. And of course the results are plotted in the latest file here, in this auto plotter data results. So let's take a look at line 1. Yes, line 1, so line detector number 1, and you could see release volume fraction. So that's 9%. So it's detected 9%, and so if it's set at a setting of less than 9%, it will detect. Line detector number 2 will detect about 41%. And of course you could trace it to detect any one of the parameters. It doesn't have to be just gas fraction or volume fraction of the gas. It could be anything that is detected, and that includes temperature as well. And so that's how easy it is to carry out a quick analysis of a gas detector layout in Explo CFD now, using dispersion of a jet release. If you have any questions, please don't hesitate to get in touch with us. Our email is shown here. I hope you enjoy using Explo CFD.